Okay. Hi, my name is Karina, and I'm just going to talk to you about this toy project that I wrote one night. I hadn't coded in like a week and a half, and I needed something to get me back into the groove before I got back into the project that I'm building. And so, since I'm building a project that uses SVG and React, I thought I'd play around with that. So what I did was downloaded the geography of the Oklahoma City bus system off of this feed that they provide, and wrote an app. Oh, it's on the other side. Wrote an app to show that. So this is our bus system's website, and under Business Center here, if you go to Transit Data Resources, there are these files. And this is the link. It's pretty well hidden to get it. But if you click on that, then you will get this zip file. And this has all sorts of information about the bus system in it. And the one that we're interested in here, since we're drawing a map, is this shapes.txt file. When we open that up, it's a CSV file that has some shape ID, latitude, longitudes, and then the sequence of points and how far you've traveled along that in some unit system. And in this code here, we've got the get data thing off of their website. It's just a typical fetch thing, and then there's you have to get into a zip file and pull the shapes file out of the zip file and all that. So once you do all of that, then we will parse that data out some. And we pull in this CSV file, and we take off, well, first thing we want to do is get the unique list of shape IDs, because you see in this first column here, it's all ones, and then you scroll down a little bit, and it's all 10s, and so it's like shape ID number 1, shape ID number 10, and so we want to pull together all of those points that represent each of these shapes. So we pull in the CSV, we chop the header row off, and then we filter out all of the records so that we got this ID number here. And we sort out to make sure that this sequence is correct, make sure that we're keeping it in order, because whenever they generate this file, they should keep it in order, but there's no guarantee of that. So since we're doing data processing, we want to make sure that we know what we're dealing with. And then we're going to take these latitude, longitude points, and we're going to turn it into something that we can work with. Now, the thing about SVG, the graphics format, is that it's only good to single precision. So if you have coordinates that are 35.12345 decimal places, or if you translate it to like local survey feed or something like that, then you have 6 digits decimal point, and then you get 1 decimal point after that. So you have problems with precision if you don't translate it to some local coordinate system. And so that's what we do here. We're just going to take all of these latitude, longitude values, and we're going to multiply them by 1,000. And put that into our data variable. And whenever it reloads, then it's going to take that data that we have here, and we build this SVG element. The SVG is just the graphics format that's standard on the web. And you need this view box, which I found experimentally, but basically this means the upper left coordinate and the lower x coordinate, the left side, the upper y coordinate, and then the width and the height. And we're going to use a path element here. We have to make this d value. And so you start with an m, and you say move the cursor to this xy value. And then you say big L for draw a line to this other value. And so you start with an m, and then you join together the rest of them with an L. And whenever you render all of this out, you end up with an upside down map of Oklahoma City. And the reason it's upside down is because latitude increases going north, but SVG increases going south. So, in order to fix that, I'm going to pull this back over here for a second. I'm going to uncomment this scaling transform, and I'm going to say that I want to scale it by 1 in X and -1 in Y. And then that'll flip it over. But we're still not quite done yet, because if you zoom in here, by making that bigger, of course, these are over in Midwest City, and these rectangles are actually 1 mile squares. The reason that they're showing up flattened like that is because the Earth is a sphere. It's not a flat surface. And so we're going to correct that. And the way we're going to correct that is we're going to do a little bit of trick. So this is a cross-section of the Earth. And so the core is in here. And then the radius goes out to here. This is someplace on the equator. We go up to the surface. We go up the surface about 35.5 degrees here, and you get to Oklahoma. This is where we are. And so this radius is the same on this line and on this line. We have some angle here, so by vertical angles in geometry, this is the same angle up here. And so this radius of the Earth is multiplied by the cosine of this angle in order to create this. Well, this is the same kind of thing, except we're taking, like, imagine you're standing here looking this way, and this is north-south, and then this is east-west. And so this could be a degree of longitude. It could be a second of longitude, just some very small amount. So since we're working relatively locally on the Earth, we can approximate it as a sphere. And in order to correct this squishiness here, that squishiness is because it's rendering that rectangle as a square. So we want to turn that square back into a rectangle. So we're going to do a little bit of math here. We're at about 35.5 degrees north. So we'll do 35.5 cosine. And that gives us about 0.81. There's a reciprocal button on here somewhere, I'm sure. Well, we'll just do this maybe. Cool. All right, so we're going to take that number, 1.23, and we're going to put it in here where our scale is. We'll change that to -1.23. And now those squares show up as squares instead of rectangles. So React, SVG, and pulling data off of the internet in a very nerdy way.